Mahela Bandara from Faculty of Engineering, University of Peradeniya, Sri Lanka. I am going to present our based on analyzing and predicting the volatile market patterns for trading in international markets using a digital twin. Introduction. First, I introduce the topic and next move on to the methodology, experiments, and findings. Finally, the expected outcomes and deliverables. Our goal is to find ways to increase profit and reduce risk when investing in synthetic digit trading markets like derivative using the power of deep reinforcement learning. This is our introduction. What is digit trading? It's trading based on the last number of the market price. We use online platforms to trade, choosing options like higher, lower, or different. You make money based on how accurate your predictions are. From our research, we learned that reinforcement learning is better for trading markets than other methods like supervised learning or time series analysis techniques as shown in the table. So, here's how digit trading works. The first row shows the time frame, updating every 2 seconds. The next rows show the last number of the market price and our prediction. After 5 tries, if our predicted number matches the actual last number, then we get a win after 5 consequent losses. Methodology. We choose the derivative trading platform because it has tools for setting up trades through special programs. They offer a demo account that lets you practice trading in real markets with virtual money. The initial steps in the methodology include creating a digital twin to simulate a digital trading market, incorporating market participants, trading rules and regulations. We then focus on different trade styles such as matches, differs, greater or lesser based on the investor's risk profile with position sizing and rebalancing tailored to these styles. Data collection for training. The DQN agent involved using pre-collected data from websites and real-time API requests over several months. After cleaning the data, it was used to train the DQN agent with further details to be explained later. The sequence of past digits and their probability distributions are input to our custom designed neural network, part of a deep Q network. This network predicts values based on the data using results from derivative trading platform. A reward is calculated to give feedback to the agent, helping it improve its decision making. Deep reinforcement learning uses a reward function that stabilizes feedback even during sudden changes by incorporating natural logarithmic functions. The DQN agent balances exploring new strategies and exploiting known ones, training itself to make better decisions. It updates Q values using reward, Bellman equation and gradient descent to guide the next trade. The neural network using the DQN agent is hybrid deep learning model design, specifically for predicting complex sequences like those found in financial markets. It incorporates methods from pseudo-random and quantum random number prediction to be handled synthetic trading markets data complexities. This is our neural network architecture. The initial convolution 1D layer were crucial for identifying key features like sudden shifts or trends in the input data, which includes sequence of numbers and their probability distributions, signaling upcoming markets movements. These layers use different data sizes to capture a wide range of details. After feature extraction, LSTM layers retain long-term information important in financial markets where past trends influence future events. This improved the model's ability to predict market behavior. Dropout layers were added to prevent overfitting, making the model more reliable across different datasets. The model proceeds recent market data and numerical sequences to ensure timely relevant predictions. It outputs Q values that estimate potential rewards, guiding the DQN agent in marketing the best decision for the next trade. Investment handling by balancing risk levels and rate of return. The DQN agent's strategy of matching last digit often result in small losses with low risk of big losses. However, one large loss could wipe out the account due to the ongoing investment. There is a safe zone where trades results in small losses, which is denoted by green dots, between rare large losses, which is denoted by red dots, to achieve predetermined profit per trade's risk profile. By focusing on this zone, we can minimize losses until a win, avoiding the high risk linked with large portfolios and creating a more manageable investment strategy. Position sizing rules were set to manage trade exposure, keeping the strategy balanced with the investor's risk tolerance and return goals. Consecutive losses were managed using martingale strategy, where the investment increases after each loss to recover and make a profit on a win as shown in diagram. After 15 consequent losses, uh, our capital would be washed. Uh, so this is the martingale strategy. This suggested that the DQN agent was more likely to make correct predictions on the first attempt with zero consecutive loss. As you can see, green dots have high frequency with less inconsistency rather than any other range of black dots. Experiments and findings. The DQN agent's predictions, which is denoted by green, had fewer consecutive losses, showing higher accuracy compared to random predictions, which is denoted by black. This higher frequency of consecutive wins highlights the digital twin ability to reduce trading risk by making more accurate predictions with fewer losses. The next image demonstrates how closely the DQN agent predicts market behaviors, capturing both exact and similar patterns. The DQN agent exhibited a higher frequency of consecutive wins and reduction of successively escalating losses compared to the random agent. So we introduce a loss filtering operation again. So the loss filtering operation is the if a win is achieved by the agent, do the next trade in the virtual real trading platform, and if a loss achieved by the agent, do the next trade in demo trading platform. Therefore, more stable and less risky investment plans were achieved when utilizing the DQN agent prediction results by this. To leverage this advantage, the digital twin perform as shown loss filtering algorithm on DQN agent's consecutive loss predictions. So, performance comparison after loss filtering operations, comparing the distribution of consecutive losses after applying loss filtering, the DQN agent showed more trades with fewer and shorter losing streaks, indicating better risk management and increased rate of return compared to the random agent. The frequency distribution plot shows consecutive losses for the DQN agent and a random agent after loss filtering by digital twin. The DQN agent distribution leans heavily towards zero consecutive losses, indicating more frequent small wins than the random agent. This has helped increase the rate of return. The DQN agent also has fewer maximum consecutive losses, showing improved stability and consistent performance. This reduction in volatility markets the DQN agent more reliable and reduce risk in practical use. This solution helps investors to choose the best trading method and strategy based on their risk tolerance and desired returns. Investors can access the DRL-driven digital twin for copy trading through an automated bot. Additionally, the system can be expanded to work in stock trading, cryptocurrency markets, and even develop into multi-agent systems. So this is the expected outcome and deliverables. So the copy trading is tested by several API program. So this is the end of our presentation. Thank you.
Okay. Thank you, Mr. Jayakodi. So, if there's any question for the presenter?
Have you tried your algorithm or tested it on real world data set in the real time? Is my question audible?
Yes, we tested it real time.
Yes, sir.
Time.
Yes, sir. It's tested in the real platform.
So, is there any other questions? Okay. If not, thank you very much. So, we'll move on to the next presentation. So, the next presentation is enhancing calls to query expansion, a fusion of LSTM with global and BERT model. So presenter is Ms. Nasia Bibi. Okay. So you have about 10 minutes time to complete your presentation. So I will let you know about 2 minutes before what time you have.
Bismillahirrahmanirrahim. Assalamu alaikum. My name is Nazia, and I'm feeling very excited to present on the topic that actually merges software engineering with deep learning. And feel privileged to have this platform to engage with you and to share or discuss on this area. So let's jump into the main presentation. The topic of the presentation is enhancing code search through query expansion, a fusion of LSTM with GLOVE and BERT model. So these are the contents that I am going to cover during the presentation. According to the study published by Pakistan Houses Software Association, that 30 to 70% of the time is spent by the developers on actual development, whereas 10 to 30% of the time is spent on actual searching of the desired piece of code. So, due to the rapid growth of the data, the software repositories are filled with lot of source codes, and due to the searching of the code out of these repositories become very critical. Although there have been very traditional approaches have been proposed, but these traditional approaches suffers from the terminology inconsistency, and most of the approaches relies on keyword based retrieval. Researchers are still trying to propose deep learning approaches to enhance the code search, and we also try to propose an approach or a model that actually uses BERT and GLOVE for word embedding, and LSTM with attention mechanism is used in the proposed model. These are the objectives. The first objective is to develop a model with the aim to reduce the semantic gap between the query and the code. And the second objective is to assess the performance of the proposed model on a benchmark dataset available specifically for this purpose, and to compare the results of the proposed model, with the existing and established baseline models. So the last objective is to incorporate the attention mechanism within the model with the aim to enhance the accuracy of the proposed model. So these are the research gaps. Existing methodologies struggle to locate desired code snippets with high precision. Second, code retrieval is hindered by the inaccuracies between user input and code terminologies, complicating the search process. Traditional code search techniques fail to effectively capture the contextual meaning and the relationship between the query and the code. And the last one is the mapping between the user query and the available code snippets is often insufficient, leading to ineffective code retrieval. So this is the research methodology. I start with conducting the literature review, and after conducting the literature review, I have pinpointed the problems, and after that I have formulated the research objectives, and then I try to look for the benchmark datasets, and for this study I have utilized two benchmark datasets. So with the dataset in hand, I developed a model and implement the model, and in order to evaluate the accuracy of the proposed model, I have conducted a series of experiments, and the results of the proposed model is then compared with the existing and established baseline models. These are the two datasets that I have used. The first dataset basically comprises of 4,85,812 query code pairs, and the second dataset comprises of 5,42,991 query code pairs. So now let us discuss the proposed architecture of the model. The model starts processing when user inputs the query. The query is tokenized and is passed to the query embedding layer. So the query embedding layer is basically responsible to generate two types of embedding. The first is the GLOVE embeddings, and the second one is the BERT embedding. So the BERT embedding basically captures the contextualized word representation providing a deep understanding of the intrinsic relationships that exist between the query and the code. Third, the GLOVE and BERT embeddings are combined and are passed to the LSTM layer for the processing. These two embeddings are basically concatenated, and the concatenated embeddings for each word basically creates a richer vector representation that combines both the static and the contextual information. So the output of the query embedding layer is then passed into the LSTM layer, and the LSTM layer is responsible for capturing the pattern and the sequential dependencies within the enriched embeddings, and the output generated by the LSTM layer reflects the contextual and sequential relationship between the query and the code. And the output of the LSTM layer is then passed to the attention layer, and the attention layer basically computes the similarity score by focusing on the important elements in the query and the available codes. So the attention basically dynamically assigns the weights to the important part of the input query. So there comes the final step, and for the ranking, we basically utilize two evaluation matrices. The first one is the success rate, and the second one is the mean reciprocal rank. So this is the experimental setup. As I have already told you that I have utilized two data sets. So the following table basically represents the split of the data set into the subsets, training, validation and testing subsets respectively. These are the baselines that are used for the comparison purpose. So the LSTM layer has 128 hidden units with 2 layers, and the batch size is set to 32, and the training rate is set to 0.001, and an Adams optimizer was used for the optimization process. So for the 100 epochs with a dropout rate of 0.2 and using a Tesla V100 GPU with the above settings, for 100 epochs can approximately take 6.2 hours for the data set 1 for the training process and 4.2 hours for the data set 2. So these are the evaluation matrices. The mean reciprocal rank and the success rate. Now let us discuss the results. As you can see that the proposed model achieves higher accuracy in terms of precision, in terms of success rate and mean reciprocal rank in case of dataset 1 and in case of dataset 2. So this indicates that the proposed model effectiveness is not only returning the relevant results at the top of the list, but also ensuring a high proportion of the relevant results across various positions in the rank list. So these are the results. As you can see that the training and the query processing time is comparatively low in terms of the proposed model, and we have also tested the model with different variants, and as you can see that the model with GLOVE, BERT, LSTM and attention mechanism achieves the higher accuracy. So conclusion, we have proposed a model which basically utilizes GLOVE and BERT embedding for query expansion, and we have used the attention mechanism which actually assigns the high weights to the similar words that exist between the query and the code. And the evaluation results shows that the model achieves the higher performance, and in future we can also incorporate ASTs and control flows in order to assess the performance of the proposed model. Thank you.
Thank you very much. So you are right on time. So any question for the speaker?
Did you do any ablation study to study the effects of adding GLOVE embeddings in in comparison to using only BERT embeddings?
Yes, sir. We have tested the model with different variants. As you can see that we have tested the model with GLOVE with LSTM, and then we have tested the model with BERT and LSTM.
All right.
And
All right.
yeah.
You trained on one data set. Did you try training on one data set and then testing on the other to check
Yeah.
the generalizability?
Yes.
What were the results?
The results, as I have already shown you, that for the data set one, that the success rate is 0.0.
No, that is training on dataset 1 and testing on dataset 1, right?
Yeah.
I'm asking about training on one dataset and testing on the other.
No, no. I have trained two data sets and
Separately.
Separately.
Okay.
Yeah.
My final question. The split that you used, is it given by the dataset publishers or
Yeah,
did you use your own?
It is given by the publishers.
Okay, perfect. Thank you.
Any other questions? Not. Thank you very much. So we'll move to the next presenter. So the next presentation is machine learning based detection of Java semantic clones using low level abstract compiled representation. Presenter is Mr. Fahmi Kururada. Sorry for mispronouncing.
Good afternoon, everyone. My name is Fahmi Kurada. I am a PhD research scholar at Peshawar University. Today, on behalf of my college, I'm going to present our work on machine learning-based detection of Java semantic colon using low-level abstract compiled code representation. In this presentation, our agenda will start with a brief introduction, then we will move into clone detection technique. After that, I will delve into the motivation behind this work, leading into research methodology that we employed. Next, I will walk through the experimental evaluation, and I will conclude this presentation with our findings and potential direction for future work. As we know, developing a new software is a costly process. It requires a considerable time and effort. So software developers are reusing an existing source code in order to reduce this time and effort. So this similar code fragment resulting from this practice of copy and pasting these code fragments are called code clones, and the process itself are called code cloning. Actually, the process of cloning accelerates the software development, but it has severe impact on software quality and maintainability. It leads to bug propagation, and also it increases the software size, and also it increases the size of the software system, and also erode the architecture of the software system. Actually, in literature, there are two categories of colons. We have syntactic colon, which include three types, which are type 1 and type 2 and type 3. And semantic category, which include type 4. This figure shows you the different types of colon. Actually, between type 3 and type 4, there are a spectrum of colons, which are further categorized into four colons, which are actually they are categorized based on their syntactic similarity percentage. This category include the very strongly type 3, and moderate type 3, and weakly type 3 and 4. In software industry, code cloning is considered a critical issue. Researchers indicate that between 7 and 23% of software systems are a similar code. And also several software engineering tasks such as refactoring, reusing, code searching, and software evaluation analysis and other tasks require the extraction of code clones. Consequently, the identification of code clone is emerged as an active research field in software engineering. In literature, there are different techniques have been proposed. This figure shows you categories of these techniques that were proposed in the literature. Actually, we have traditional technique and machine learning technique. All of these techniques follow a process contains of three steps. The first step, which is pre-processing and code representation, and after that, matching algorithms. The motivation behind this work, as we know, synthetic analysis tools such as SWOT framework generates different intermediate representation for source code analysis. Each intermediate representation over a level of abstraction that provide multiple advantage for source code analysis. In this work, we are using an intermediate representation called BAF, which is a kind of GAFA bytecode, but it's more abstract than GAFA bytecode. Actually, these intermediate representation are generated by using SWOT framework. In this figure, to show you the potential of using this intermediate representation, as you can see in this figure, we have two code fragments that compute the sum of two numbers, the left one for integer and the right one for the floating number. If we generate the bytecode, as you can see, the generated instructions are different. But if we use above intermediate representation, the generated instructions are almost the same. Another example to show you the potential of BAF intermediate representation. Also, this figure shows you two code fragments that perform the same functionality, but they are implemented by using different static structure, syntactic structure. So, to use the BAF, when we use the BAF intermediate representation, in order to represent this code fragment, as you can see, the generated instructions are almost the same, even if the implementation is different. But the functionality is still the same. Finally, this figure shows you a code fragment which contains an unused variable and also a dead code section. When we use a BAF optimized BAF intermediate representation, this representation allowed us to just generate the instructions that are more important in constructing the meaning of the code fragment. As you can see in this, in the generated BAF intermediate representation, it ignores all the unused variable and also it ignores all the dead code because they are not important to construct the meaning of the code fragment. Our proposed approach contains two phases. In the first stage, we have a training phase. In training phase, we have to build our data set. We select a data set actually from a huge data set. It's a Java corpus, which contains a colon function and non-colon function. Actually, this data set converted into BAF intermediate representation. These data sets are fed into a process called BAF feature extraction. In this process, we have three steps to do. First, we recognize the sequence and calculate the frequency of each instruction. Then we categorize this instruction into 6 categories. We have a memory instruction, and also we have arithmetic logic instruction, and so on. After that, we calculate the similarity between these categories based on this equation. Finally, the main output from this process is a similarity vector, which include 7 values that represent the similarity between these code categories. These similarity vectors are fed into machine learning classifier in order to train the similarity between code fragments. In testing phase, we take the Java file and we compile it and we convert it into BAF by using SWOT framework, and then we extract the function, and after that we build the intermediate representation pair and feed it into the BAF feature extraction. And after that, the generated similarity vectors are fed into a classifier that we train in the training phase in order to determine the types of colons that are located in this file. To evaluate the 2 minutes. To evaluate this approach, actually we use a data set called a big data set called Big Clone Benchmark, which is well recognized for assessing Java code tools. This is some statistics tools, statistic information about this data set. To evaluate our proposed approach, actually we evaluate 3 research questions. The first one, the performance of our approach. As we can see in this figure, we randomly we selected 15 classifiers and trained them based on the proposed feature. As we can see here, the ensemble technique outperformed the individual technique, and also ExaBoost technique has the ability to detect more semantic colon. This figure also shows you more detailed information about the detected semantic colon. As we can see, the ExaBoost has outperformed the other technique in detecting very strongly type 3 and strongly type 3 and moderate type 3. While the light GBM classifier has the ability only to detect the most difficult semantic colon, which is the weak type 3 and 4 colon. The second question, as I told you before, we classify the buff intermediate into 7 categories. In this research question, we want to investigate which categories are participate more. What we find in the first experiment, we include all the categories, and the result, as you can see, it's 94% for ExaBoost, the performance in terms of F1, and 93% for random forest. If we exclude the memory categories, the performance is decreased by about 10% for ExaBoost and 8% for the rotation forest. In the next 6 experiment, the performance decreased between 2 and 5%. Finally, if we in experiment 9, if we exclude the memory and control flow and the method invocation, as we can see, the performance is dramatically decreased. And finally, in the experiment 9, when we add the memory, the performance is getting better again. This means memory category instruction are participate more in detecting semantic colon. In the research question 3, we compare the performance of our proposed technique with the 10 clone detector technique in terms of recall and F1. In terms of recall, we can see that our model has the outperform other technique in detecting strongly type 3, moderate type 3, and weak type 3. Okay, just 1 minute. And also in terms of F1. Finally, in this work, we're proposing a new machine learning technique for detecting Java semantic colon. Our result indicate that our feature can hold more semantic information about the code fragment, and also we can find that the ensemble technique has the ability to detect, to outperform the individual classifier, and also memory category instruction participate more in detecting semantic colon. Also, our proposed technique has the ability to outperform better than other technique. In future, we are planning to use this technique and other intermediate representation with deep learning technique and transformer architecture. Thank you.
Thank you very much. So, is there any question from the audience? Actually, I have one question. I'm not familiar with this area, but I have a very generic question. So, the people are using ChatGPT to generate the code, right? So, can you also identify this kind of code which are generated by ChatGPT?
No, actually, we are not targeting this area. Okay. Actually, we have a Java code. Just we want to determine the similarity between this code.
Okay.
We don't looking for the code generated by using this one.
Okay. Yeah. Okay. Thank you very much.
Thank you very much.
So we are moving to the fourth. Okay. Yeah, we are moving to the fourth presentation. Is an introduction to the bidirectional recurrent neural network in forecasting commodity prices. So presenter is online, I believe. So Mahela. Okay, okay. Okay, so then let's move to the first presentation. So it's the bug hunt, unveiling insight through the mining and analyzing in source code. Mr. Muhammad Waqas, you have about 10 minutes time.
Hello. Bismillah ar-Rahman ar-Rahim. Start with the name of Allah Almighty, who retains the dignity and humiliation. Good evening, my respected teachers and mates. It is with great honor that I stand before you today. My name is Muhammad Waqas, and under the mentorship of my visionary guide, Mr. Sajid Bashir, I have had the privilege to delve into the complex world of the bug hunt, unveiling insights through mining and analysis in source code. This is the outline of a recent research study. Introduction. Over the past 20 years, open source tools such as static program analysis are developed to detect source code bug. The continuous evaluation and complexity of software system poses a considerable challenge to maintain their reliability and functionality. Identifying and rectifying bugs are crucial. Identifying and rectifying bugs in source code is fundamental to ensure software quality, user satisfaction, and overall system stability. Bug detection takes a lot of resources. So various tools in static program analysis address this issue, but many lack robustness, primarily relying on manual defined patterns. The process of bug fixing is also time consuming. As reported by this ROGWave software report, developers allocate half of their time to debugging. In order to alleviate the issue of bug fixing, the bug prediction has been studied extensively by the researchers. Automated bug detection and diagnosis have gained a substantial attention as indispensable tool to streamline the bug resolution process. Machine learning has earned a lot of fame in present time. Many machine learning models have been built and tested on various grounds. The initial stage in bug prediction is crucial, and it includes selecting the right feature matrix, which significantly affects the accuracy and complexity of the model. Therefore, it is very important to choose feature matrix carefully. This study is primarily focused on the feature engineering. It holds the extraction of features, fine selection of features to get the optimal information. Once the key features are ready with all the relevant information, this study will take the final step of application of classifier to evaluate the performance. Bugs in source code can arise from a variety of sources, like programmers made mistakes while writing codes, such as typos, syntax error, and logical errors. These errors can result in unexpected behavior of a program crash. Syntax error and typos are usually caught by the compiler or interpreter and prevent the code being executed until fixed. But semantic and logical errors are often more challenging to identify and debug because they do not cause an immediate crash or error message. These bugs can lead us towards the future failure or unexpected behavior of the software. There are different types of bugs, such as buffer overflow, format string, memory leak, integer overflow, and uninitialized variable. The current study is focused on the buffer overflow bug type of C language. So we need to understand what is the buffer overflow. The buffer overflow is a type of software vulnerability that occurs when a program writes more data into a buffer. A buffer is a temporary storage data of a memory. Here comes problem statement. As the software becomes more complex, this is an associated rise in the expected number of potential bugs that might slow down the fast application development cycles or cause problems in future stages. However, this problem can be addressed by using bug prediction based on feature metrics. Nevertheless, available techniques are yet to develop with an optimal suite of feature measures. To end this investigation chooses a minimum but highly effective set of feature metrics from raw source code to ensure that the model does not become overly complex and yet maintain the accuracy. The core objectives of the research study are: understand the challenges by analyzing the data of source code files, data mining to identify the error patterns, feature engineering to extract the meaningful features and more authentic information, evaluate the performance of the model based on the available features. These are the basic research questions of the study. The first question is how data mining and data analysis can lead us towards the solution of bug detection in source code. The second question is, does the data analysis and data mining have significant impact on the performance of bug identification technique? And the third question is, what is the impact of different options at various stages of data mining has on the performance of classification algorithm? This slide is presenting the basic steps of our research design and methodology. Here is the block diagram of our proposed model. The dataset. Dataset is the first phase of our proposed model. The initial challenge was the lack of clean, open and ready to use dataset. Instead, we have acquired the raw source code organized in directories, subdirectories with .c extensions including the clause information. Non-buggy files are featured with the keyword _OK with their names, distinguishing them from the buggy files. In order to formulate the dataset for current purpose, a self-generated Python script was written which systematically reads each .c extension file to extract the content of that file. After reading the concerned file, the script generates an object of that file, and the object which contains the content of the sample. The object were then compiled into an array. To facilitate the usability, this array subsequently converted into a well-structured .csv file. Okay. This is the structure when we have finalized our data set. We have total number of samples 1164, where we have 873 samples are buggy and 291 are non-buggy. Here we have data preprocessing. We have performed data processing, pre-processing here. We can see the two samples, a same sample in two forms. The first form is before pre-processing and the second form is after pre-processing, and we can see a well planned, we have the relevant code here. After that we have the feature selection. In this study we have utilized the turn frequency and inverse document frequency. We have utilized two techniques such as unigrams TF-IDF and bigrams TF-IDF. So we have here two different data sets based on unigrams and bigrams. Then we have performed feature selection. Initially, recursive feature elimination algorithm was used to select the features. After the feature selections, the original feature measure was 148 in unigram set and 612 features in bigram set. And after the application of RFE, we have gained the 74 features in the case of unigrams and 306 features in bigram case. Dimensionality reduction is essential to streamline complex data by reducing its feature space while retaining crucial information. Here we have applied the dimensionality reduction by using the principal component analysis, and these are the result what we have gained after application of PCA. Experiments and results. We have performed, we have chosen the k nearest neighbor as a classifier because we were experimenting basically on the feature engineering. So when we have the features, we have the desired features, we can perform any algorithm on it. So we have chosen k nearest neighbor for now, and we have tested its 6 different variants like classic KNN, weighted KNN, adaptive KNN, radius neighbor KNN, parallel KNN, and kernelized KNN. These are the evaluation matrices: accuracy, precision, recall, and FR measure. Because our data set was imbalanced, so we will consider the accuracy and F1 measure. Before deeper dive, here is the general overview of X-fold cross-validation. We have used 6-fold cross-validation. We can see here on the each split, fold 1 is set for. After all the experimentation is done, here we have the comparative discussion slide. This slide is presenting 2 summaries. These summaries contains the best performances of CKNN on different settings and the best performances of WKNN on different settings. Both the highlighted rows of first summary is presenting that the CKNN performed optimally on the bigram data set based on dimensionality reduction by using the cross-validation, but the WKNN, on the other hand, the WKNN performed on the same bigram data set without cross-validation and without principal component analysis. Aim of this research is to find the answers of our 3 research questions. The first question was presented in previous slide. So the answer, yes, the data mining and data analysis can lead us towards the solution of bug detection. And the second answer, yes, data analysis and data mining have significant impact on the performance of bug identification technique, and different options have different impacts at various stages of data mining has on the performance of classification algorithm. Thank you.
Okay, thank you very much. Is there any question from the audience?
Thank you very much for your very informative presentation. So just wanted to ask that what was the rationale behind using the principal component analysis, and did you also try to use the singular vector decomposition SVDU as well with PCA, which is the more generalized form of PCA?
Yes, we have utilized 2 different types. One was based on the principal component analysis, and the second one was based on the recursive feature eliminations. We have produced 2 different data sets on the basis of these tools, and we have performed multiple experiments on these data sets. So we have multiple results, and at the end we have chosen the best results among all these. So we
Okay, so do you plan to enhance your work with further other techniques, because you use two algorithms, right?
Yes.
There are a couple of others which are more advanced. So PCA is a bit, it's been like 15 years it's been in the machine learning domain. So right now there are more advanced techniques as well which you can use and get more accurate results. In future, I think you can do that.
Yes. In future, we are planning to use other techniques and other models as well, and we take this theory or this you can say proposed model with other TL models or LLM models like that.
Thank you.
Thank you.
Can I have a question? Can I ask a question, please?
Okay, sir.
Since your data set is very unbalanced,
Yes, sir.
while applying k-fold cross-validation, did you ensure the splits were stratified, or you just randomly split them?
No, it was stratified. We have used the ratio of 80 and 20%. 80% for testing and 20% of...
No, that's, you applied 6-fold cross-validation, right?
Yes,
So it will not be 80-20, it could be...
No, it's 6-fold cross-validation is, yes, we have applied with these, but we, data splitting, I was asking about the data splitting, and you are asking about the 6-fold cross-validation. And for 6-fold cross-validation, we have randomly utilized, because our data set is, you can say, very small. So we have considered the division of the data set properly. So each fold have the same sample size.
Same sample size, but do each fold also contain the similar proportion of both classes?
Yes.
Okay.
Yes.
Okay, thank you very much. I think that concludes the session. So there is an announcement from the organizers. So the next session is going to be start at 3:15, not at 3:30. So you can have a coffee break for 30 minutes. So before that, I think there's a presentation of the certification.
Thank you all. Okay, the next session will start at 3:15 and we will conclude it at 5 p.m. So be on time, okay?